Values of trigonometric functions. Special angles. It is useful to remember the following two special triangles which are used to define the trigonometric functions of the three special angles: 30 degrees, 45 degrees and 60 degrees. So special angles are 30 degrees, 45 degrees and 60 degrees. We use the two triangles below to write out the exact values of the sine, cosine and tangent of the three angles listed above. Note that we will use SOHCAHTOA to write three primary trigonometric ratios. So let's look at these two triangles. First triangle is 45, 90, 45. So one angle is 90, other two are 45, 45 each. Opposite of 45 degrees are 1 and 1 as side length. And using Pythagorean theorem, if these two side lengths are 1 and 1, 1 square plus 1 square will give us 2 square. 1 plus 1 will give us 2. Square root that will give us a square root of 2. Similarly, another triangle is 90. This is a 90 degree. 60 and 30. Opposite of 30 degree is 1. Opposite of 60 degree is length root 3. And the hypotenuse is 2. Again, opposite of 60 degree is root 3. Opposite of 30 degree is 1. And hypotenuse is 2. Now using SOHCAHTOA, we can write down values of these 9 different trigonometric angles. Sine 45 degrees here, sine is opposite. So from here, if I were to look from this angle, this side right here is our opposite. This right here is our adjacent. And this right here is our hypotenuse. Now if you were to look from here, because it's 45, 45, it is not going to matter. So opposite here, adjacent and hypotenuse. So sine 45, SOHCAHTOA. So let's quickly write SOHCAHTOA here. So SOHCAHTOA. Okay, sine is opposite over hypotenuse. So sine 45 degrees will be 1 over square root of 2. Cos 45 degrees then is adjacent over hypotenuse. So that is also 1 over square root of 2. And tan 45 degree is opposite over adjacent. So 1 over 1, which will simplify to 1. Now for 30 degrees, depending on from which angle we are looking at. So let's say we were looking from this angle right here. From this angle, this side is our O, this side is our adjacent, and this side is our hypotenuse. So for 30 degrees, opposite is 1, adjacent is root 3 and hypotenuse is 2. So then sine 30 is half, opposite over hypotenuse. Cos 30 is root 3 over 2. And tan 30 is opposite over adjacent. So 1 over square root of 3. Now let's say we were looking from this angle right here. According to that angle, opposite is root 3, adjacent is 1. And hypotenuse remains same 2. Hypotenuse does not change. So from there then, sine 60 opposite is root 3 over 2. Cos 60 is adjacent. So that's 1 over hypotenuse 2. And then tan 60 is opposite over adjacent. So that's root 3 over 1, which will be just root 3. Now some of us know how to rationalize this. So if you were to write this as some of them as rationalized form, we can say 1 over root 2 is equivalent to root 2 over 2 multiplied numerator and denominator both by root 2. I'll accept 1 over root 2 and root 2 over 2 root both. The second one is better choice, but this one will also work. So for this one then, it will be also root 2 over 2. 1 is same, half is okay, this is okay. 1 over root 3 can be rationalized as root 3 over 3. This one's also okay, this one's okay, and this one's okay. So these three we could have rationalized it more. Now let's say same thing if you wanted to look at in terms of radian measure. Radian measure looks like this. So 45 is pi over 4 as we saw earlier. So let's quickly write them. This is 45 degrees, this is 45 degrees. So pi over 4, pi over 4. Same triangle like previous, 1, 1, root 2. And the another one is 1, root 3, 2, where pi over 3 is 60 degrees. Pi over 6 is 30 degrees. So before we saw in degrees, now these are in the radian more. So let's see how we would deal with it if it was in radians. If it was in radians, okay, let's quickly write down here that 45 degrees is equivalent to pi over 4 radians, pi over 4. 60 degrees is equivalent to pi over 3 radians, and 30 degrees is equivalent to pi over 6 radians. Okay, and then again using SOHCAHTOA, we can say sine pi over 4. Let's say if we were looking from here, this is our opposite, this is our adjacent, and this is our hypotenuse. Because pi over 4 is both angles, doesn't matter from where we write it, sine pi over 4 will be basically 1 over root 2, which we can rationalize as root 2 over 2. Cos pi over 4 will be then same, 1 over root 2, which will be root 2 over 2, and tan pi over 4 will be 1 over 1, which will be 1. Now if we were to look from this angle right here, pi over 6, this will be our opposite, this will be our adjacent, and this will be our hypotenuse. So from there then, sine pi over 6, we can say opposite over adjacent, so half. This one is root 3 over 2, and tan pi over 6 is 1 over root 3, opposite over adjacent, which we can rationalize as root 3 over 3. Now if we were to look from this angle right here, this will be our opposite, this will be our adjacent, and the hypotenuse remains same. So sine pi over 3, from there opposite over hypotenuse will be root 3 over 2, this will be half, and this one will be root 3 over 1, which will be root 3. So it's very similar numbers from previous ones, just that now we are working in radians.